G'day, guys. People have been talking about, I'm getting an increase in my blood sugar levels on a carnivore diet. There's been talk about, glucagon like peptide 1, GLP-1 by a number of people, um, different controversies about it and discussions and all sorts of things and all that. I've already done a video covering this point and sort of explaining some of the calcium related stuff. I'm going to stick it there at the end for people to actually view the previous video. But what I'm going to do is I'm just going to show a couple of studies to cover a few points. I'm not going to go through them. That's not the purpose of this video. I'll provide the links. People can go and check them out themselves. That's also the purpose. That's just to cover certain points and then give some of the genetics that I think are involved and the hypothesis that I've sort of come up with in regards to this issue and the reason for it, genetic changes in the last 10,000 years and what's behind it. I was actually going to make another video in regards to this issue, which was going to have a very different angle, but I've realized that this issue is more important. And it will be basically, we'll cover some of those points, but let me get on with it. Anyway, so let me share my screen. And our revamped. So we mostly know that, I've talked about how calcium increases GLP-1, okay? Glucagon like peptide 1. And there's plenty of literature. This is just one study, vitamin intestinal calcium absorption. The principal function of vitamin D in calcium homeostasis is to increase calcium absorption from the intestine. Calcium is absorbed by both an active transcellular pathway, which is energy dependent, or by a passive paracellular pathway through tight junctions. That's within the gut. Remember the tight junctions there? And I've done videos covering vitamin D, how it sort of tightens the junction and regulates that part. So does taurine. We won't go into that. So pretty much the active form of vitamin D, 125 OHD, which is the one where you get the stored form and you basically activate it in the primarily in the kidneys, but in some other tissues as well. The hormonally active form of vitamin D through its genomic action. So is the major stimulator of active intracellular calcium absorption, which involves calcium influx. So while that pathway is very important, there are genetics which regulate the transcription of the important enzymatic, ways of absorbing. So while vitamin D plays an important role, and we also know that dietary protein, that a lot of this is sort of a bit of a hypothesis. Protein increases intestinal calcium absorption, improves bone balance. And there's been other studies in recent times talking about vitamin D. And here you can see it is a bit of scatter, urinary calcium, bit of a scatter protein intake per grams as you go up. It's not tight. It's an R value of 7. The higher it is, it's very important. But at the same time, we don't know what the sources of protein are. Some protein, if it's plant-based, can actually have protease inhibitors, which inhibits protein uptake. So we know that as well. So obviously we're going to get a scatter, but 7 is definitely better than some of the other stuff that we talk about, cholesterol and whatever else, which is down to 0.3 and whatever. The R value is much lower, and the P value is very high. The probability of this being a fluke is unlikely with that sort of P value of 0.001. Anyway, that's not the purpose, as I said. That's just to show that sort of stuff. High protein intake stimulate prostaglandin GLP-1 and PYY release. So that's the peptide YY. which is also plays a role. Whey protein as well, covers that sort of issue. So we see whey protein has a beneficial on the incretin hormones, and that's the ones that we talk about. Yogurt, appetite control and energy balance, more studies talking about both GLP-1 and peptide YY. Both these they call them anorectic peptides. Peptides are basically a chain of amino acids. So basically they're short chains of amino acids. These are protein structures, very small protein structures, but they have these ones have a bit of an integrin role and a satiety role as well in that regard. So people have talked about these, that the importance of people talking about the importance of increasing your, here it's talking about calcium. So calcium and protein play a big role in increasing the uptake, increasing GLP-1 and PYY. So both those things do. So we know that more protein will increase the uptake of calcium, and so will vitamin D. So if you're on a carnivore diet in that regard, I'll just stop sharing that for a sec. If you're on a carnivore diet and you're vitamin D deficient, you may not be basically, and you're not eating enough protein, you may not be uptaking enough calcium. And so there you go. There's a mechanism. So either low protein or low vitamin D can have an effect on your uptake of serum calcium, to increase serum calcium. And also these play a role in homeostasis as well. Taurine as well is, and eating more meat means you're getting more taurine. Getting more taurine also because the osmolalite that regulates all the intra and extracellular ions. So sodium, calcium inside the bloodstream, primarily potassium, magnesium, primarily inside the cell. So these are the sort of things that are involved in that. So those are the three things, the big ones and all that. But there is the genetic side as well. And that is really important that we cover that point. So are your genetics involved in this? So for somebody to say, well, I'm doing a carnivore diet, I'm eating enough protein, but I'm noticing this happening to me. You go and do a test and your GLP-1 is much lower. You're noticing that your blood sugar is coming up a bit and stuff like that. You're going, what the hell is happening? And all that. It could be your genes. So let's cover that point. And there are two sort of things, calcium homeostasis being one, and the other being basically the absorption, calcium absorption, another important thing. This is where I was going to do a video saying, is an ancestral carnivore diet indicated for some people? I was going to say a quarter of the population may need more than just the sun and meat, may need also dairy products, and so that may be the missing link for that group. And that was the sort of focus, and it was more about why their serum calcium levels are much lower. People were reporting my serum calcium levels are much lower. Well, that's going to affect your glucagon-like peptide 1 as well, and your peptide YY. So that's going to affect your satiety signaling. So you've got the satiety signaling and the increase in blood sugar. And that's a quarter of the population. That's a significant amount. And people are going, well, especially people doing sort of like a paleo-esque avoiding dairy type. But I'm going, you guys have probably got genetics, and those genetics are pastoral, which are the last 10,000 years. So if you've got pastoral genes, you're more susceptible. And as a consequence, this is why, we look at certain pastoral populations that have got very high pastoral genes amongst them. They have this genetic at a more pronounced level. Those who have much lower, pastoral genes have this less likely. They may have one of the polymorphisms. That means one of the alleles. Anyway, let's go and take a look at this. Okay, so this has to do with the with more or less. This is not as much as the absorption. This is the homeostasis, and people can have an issue with homeostasis if they have this allele T, okay, which is AA. Just think of reverse A or T, same thing. G or C, just think in those terms for those who are less aware, and this affects calcium homeostasis, which can be a problem as well, and also can actually affect. So this is involved in the control of cytosolic, the cytosol inside the cell. Calcium level concentrations can increase. So these are also affecting cerebral amyloid levels as well. So they can create issues. We know the thing that actually can deal with this is taurine. Taurine regulates the ions even in the cells in the brain. So that eliminates the problem, even if you've got this genetic. That's why carnivore diet will ameliorate this condition, this homeostatic condition. So that's that part for calcium homeostasis. A carnivore diet is indicated specifically for this sort of condition. So let's move on. So that you want to see my genetics on that? I was actually looking at that. Don't do that. Go back. Anyway, there's my genetics on that. I'm a GG. So basically, I don't have a problem there at all in terms of calcium homeostasis. So I don't have to worry about that one. Now, the real one. This one here, CC. This is the one. This is the one involved with total serum calcium levels. Got it? T is the risk factor. As you can see, the majority of the population, about 75% in most populations, Europeans, Asians, Chinese, Japanese, as an indication of Asian, are pretty much the same. The Asians, on the other hand, do have this more severe form. It's small. It's about 4.5%. 4.5%. It's quite consistent, 4.4% in both Japanese and having this issue about, when it comes to calcium absorption, the really severe allele. Most Europeans have this one here. So it sort of explains the levels that we do find in terms of about a quarter of the population having a lot of osteoporosis levels. Are you getting enough calcium in your diet? Are you eating enough dairy? You carny boys and girls out there. So this is quite indicative of this, whether you're getting it from, and when you're looking at the Nigerians, which is sort of African Americans, African population, which is much lower osteoporosis issues and all that. What have we got? Look at the genetics. 93.7% don't have that problem. Only 6.3%, and they've only got one of the alleles. They don't have the worst thing, the two of the alleles. And so if you do a comparison there with 20%, 20%, and 23, which is nearly a quarter of the population, we're talking about nearly 4 times more in Northern Europeans and Western Europeans. Now, obviously, this is sort of an aggregated number of people in Utah that have got that ancestry. And we know in Utah, you've got more North Americans, like you've got Germanics and stuff like that. Where if you go to the British Isles, it's a different story. We know that the British people, and in particular the Irish, have much more higher levels of this allele. And the reason for that is because of their dairy culture, in particular the Irish. That's why they've got the best lactose-persistent genes. You are born, if you're Irish, you are born to eat dairy. And if you're not getting enough dairy in your diet, you're not getting enough, you're not absorbing enough calcium. The whole purpose why this downregulation happened is because of, at some point, and even this, these sort of Han Chinese and all that, and northern, you don't find it so much in populations in Africa or in the tropics, because just, it's primarily a larger percentage of people that are consuming dairy. So, Han, above the Han, you got what is called, those sort of regions, which is in the Mongolia, and they are very pastoral. So some of the Han people also had some pastoral history, not to the level of Inner Mongolia and all that, but, they're bordering. So there is that influence, and then there is cross genetics. Okay, let's not forget that the Mongols did conquer China for a period of time and did, so there would have been some, let's say, hanky panky. We'll leave it at that without really upsetting too many people. So some of these genes would have passed, and probably these are the reasons for it, why they have this much higher propensity. And I suspect when you look at, British Isles, you would get this as well. This is sort of averaging out all Northern Europeans and Western Europeans. But when you were looking further into populations that are more pastoral, you probably get some of these alleles as well. So this is the issue. This is the issue. You're not pulling in enough calcium to activate GLP-1. That's your problem. Okay, so let's take a look at Harry's levels. What's his level? What is he? There you go. He is basically like this 23.1%. I'm in that group. So I'm more susceptible to osteoporosis. I'm more susceptible to lower serum calcium levels. So it sort of explains when I actually went paleo that I was getting really a lot of arrhythmias and a lot of heart palpitations and all that. It was because of low serum calcium, because I can't absorb it as well. I need to consume it. So, it's the reason why. Genetics. Sorry. I know I'm a party pooper for some people who like to do a pure carnivore, no dairy, please, But, if you're in one of those, a quarter of the population, well, it's not an option, my dears. It's not an option, because you're not a Hadza. You're not a sand person of the Kalahari. You're not a traditional, you're not a Homo sapiens sapien without any adaptation. Like people, I'll stop sharing that. Like people in, like adaptations, choline adaptations for the Han Chinese, or the low carotenoid conversion for people in the British Isles, in particular Ireland. You eat certain foods for a very long time, your people are exposed, or to dairy in this case, and you know what, the body's going to go, well, these people are eating far too much dairy. We need to down-regulate the absorption of calcium. Now you transition into the modern age. You go pure carnivore. I'm a uber carnivore. No dairy for me. And then you start getting heart palpitations. And then you start getting higher blood sugars. And then you start getting all these other strange symptoms. Well, you're ignoring some of your genetics. Sorry for being a party pooper, but that's the reality. This is the missing link that people are not talking about because they do not look into genetics like I do. I had reasons to because I had an underlying conditions and I wanted to find out what the hell's going on. So I did my 23andMe and investigated my genetics to understand this. And as a consequence, you guys are getting the you could say the benefit of it, the insights that I've gained from my own experience and my own investigations and research. And now you understand why you may be getting certain of these symptoms. So these are the reasons. So to say to those sort of people, eat more protein is not going to do it. Because really, you need to eat more calcium-rich foods. Simple as that. Sorry, being a party pooper, but that's the reality. That's the missing link for that quarter of the population. And that is why people just say, well, that, and then they go, oh, well, throw in some carbs in order to basically ameliorate that issue. That means to reduce that issue. But then you're just creating other problems, deuterium issues for your mitochondria and some other derangements, Randall cycle issues and all sorts of other things. You haven't fixed the problem because you haven't investigated your genetics or you haven't considered your genetics. And most people nowadays avoid, because it's unfashionable. I mean, just look at all the plant-based nonsense out there in terms of dairy substitutes. It's not fat. It's really dairy's, like under the gun. You eating dairy? What are you? It's like you're evil incarnate. So unfortunately, we have this sort of hatred for animal foods, and dairy is taking a bit of a copy in more recent times, accused for all sorts of ailments and issues, which is just nonsense. Most of these conditions are due to pretty much things like, leaky gut and other things like that. People doing inappropriate things or haven't resolved their leaky gut due to vitamin D deficiency and taurine deficiency, which is a meat deficiency. So, as I say, sun, salt, and meat, and in this case, for 25% and dairy, and that will basically keep you in good nick. That's pretty much it. I hope you enjoyed the video. See yous.